So I've worked in a bunch of different, various roles. And more recently, I've been focused on cloud as well as DevOps. And so if you want to keep up to date with what I'm doing, you can check out my blog here, or you can go ahead and follow me on Twitter. And whenever I release like new books or pro site courses or anything like that or blogs, I put it out there. All right, let's go ahead and dive into actual content here. So this is what we're going to cover in my session here. So we're going to go through a little bit of history of what containers are, in case you're not familiar with that, in case that's new to you. And then we'll talk about what services are available on Azure specifically for containers. So containers have been around actually since the 80s, and they really started to become popular in 2013. And containers are basically they're an abstraction, right? An isolated user space where you're taking the operating system and you're taking, your storage, your work, and your application, and you're putting that all in one, uh, basically user space and bundling that together. And so that becomes portable and it becomes more lightweight compared to, virtual machines or even physical servers. And containers really have all of the components that they need in one package, including all of their dependencies. So you can actually take those containers and move them around, right? And they're lightweight. So it's a faster way to um, develop applications and get applications out there to the users and out there to, businesses. Also, containers allow software engineers to develop their applications in an easier way. It also allows operations teams to run containers in an easier way, going from the developer's machine, right, where they're developing the code, all the way to running it on the servers or in the cloud. Everything stays the same in that container. So it makes the process way easier, less issues as for troubleshooting, and it gives you much more consistency. And it also gives you a common platform for your developers and your operations people, right? So as you're moving through the different stages of the software development lifecycle, all of your dependencies, what you need for the operating system, if you need a web server, that's all packaged inside of that container, right? And moving through that lifecycle. Now, if we compare containers to virtual machines, this is how it would break down, right? So on the left, my left side, you have the virtual machines and what this looks like. So at the bottom layer, you have your physical server, and then you have your operating system, and then you have your hypervisor, right? If you're using VMware, Hyper-V, or something else like maybe VirtualBox. And then you have your guest operating system. So this is actually the guest operating system that's in the virtual machine. And then you have your dependencies for your actual application. So let's say if this is a PHP based app or a Java based app, you might have Apache Tomcat running here, right? And then you have your actual application running at this layer. So there's a lot of layers here. Now, if we compare that to containers, we still have a physical server, or this could be cloud. So this could be the Azure platform. And then we'll have an OS, right? That's running this Docker engine. And then within the Docker engine, we have our libraries. So that's our framework. So again, if you're running a web-based application, this is going to be running your web server and any other dependencies that you might have, right, to run that application. And then you have your actual application. Now, if you compare these two, there's actually less here, right, than there is with virtual machines. And with containers, really the app layer and the libraries layer is what consists of your container. And so when you need to run your containers, like boot them up, restart them, it's much, much faster. Also, if you need to move your containers around to different servers or different cloud PaaS services, it's much, much easier, right? Because this is much lighter. And so there's a lot of benefits to running containers over virtual machines. Now, there are still some use cases where you may need to run actual virtual machines, and you can run those in the cloud. Now, some of the types of containers out there, right? There's many different runtimes for containers. The most common and most popular is Docker, right? You've probably heard of Docker, and you will continue to hear of Docker. There are other container runtimes out there, though. Some that are gaining in popularity are this Cryo, and this is actually owned by SUSE Linux. Well, actually owned by SUSE. So, right, SUSE has SUSE Linux, right? So they actually have their own container runtime, and it runs and has commands and works much like Docker. You also have Containerd, and you have RKT, and there's many more container runtimes out there as well, and basically all of those are supported on Azure. The easiest one to get started with, and if you want to do this on your own, right, it's free, is Docker. In fact, all of these are free, but Docker is really easy to get started with. You can get something called Docker Desktop, and you can run that on your own local computer. And you can actually run a container on your local computer. You could develop your software and package it up in a container, run it on your local machine just to test it out and try it out. And it's all free. And then once you have your application developed, you can actually push that up to a cloud like Azure, and you can run it on Azure. So I highly recommend, if you want to get experience with containers, go download Docker Desktop and just get started with it. All right, so after you graduate college and you get out there in the business world and you're working with companies will have applications that they already have running the business, and they may come to you and want to know, hey, I want to containerize these applications. What should I do, or what kind of things should I look out for, right? And these are some things that you will look out for when you need to containerize an application. So one of those items is your application already containerized, right? So many frameworks, many applications, whether they're open source or paid applications, are already containerized. So I talked about like Apache Tomcat, you have Node.js, content management systems like Drupal and Joomla, and many, many other things. Another example is SAP, right? You might have heard of SAP. If you haven't, you'll hear of it in the future when you're in the business world. SAP just released, they just pushed out a new release, and they pushed it out on containers. Another thing is you need to know if the application is stateless or stateful. Now, what do I mean by that? Basically, the easiest way you could break this down is a stateful application needs to store the state somewhere, and it has to survive during restarts of the application or restarts of the server, right? And so if an application is stateful, it's not a good candidate for containerizing it. Stateless application will run and it survives even if you restart the server, or you restart the cloud service, or you restart the actual application, right? And so a good example of a stateless application is like a web front end, right? You just need the code for that web front end, and you're storing the data in a database on the back end, right? And so the front end component of that application is a great candidate for a stateless application. What is stateless, and it's a great candidate to containerize, right? Is the application already a part of a CI/CD pipeline? CI/CD stands for continuous integration and continuous deployment. So if you go down the software development path, you will end up working with CI/CD pipelines. It's just a methodology for, building your application after you've developed the code and pushing your application out to the environment where it's actually going to run. And containers work well in CI/CD pipelines. Another critical piece is you need to make sure that your application, the configuration, it's easy to separate the configuration from the actual application itself. And that makes it a good candidate for containerizing as well. And then the last thing is, when you get out into the business environment, they'll have applications and they may want to refactor an application to make it more nimble, make it so it can scale faster. An example there is, let's say you're running a business like Amazon, and during certain times of the year or peak times, you have more users online purchasing products, right? So you may want to refactor that application into containers so that when you have more users online purchasing products, you can scale those containers out on a moment's notice, and you can automate the scale of those containers so you can handle more load and your website doesn't go down or crash, right? Or another example is like Fortnite, right? If you're into playing Fortnite as a video game, right? They use container technology so they can scale as needed. All right, now what services are available in Azure to run containers? The most popular is Azure Kubernetes Service, right? So often referred to as AKS. This is a full-blown orchestration system. So it takes care of, all of the typical components for you, like your compute, your network, your storage. It takes care of all of that for you, and it orchestrates the containers as well. So let's say you're running a business and it's an e-com business and you get a lot of users at any given time, and you need to scale out containers, so you need to add more containers. AKS will just do that automatically for you because it's watching the performance of the compute and it knows when you need to scale those out. App service. So this is basically like running a web server in Azure. You can actually run code right on this. So if you developed an application in PHP or Java or some other language, you could actually just run that code right on app service. You also could develop an application, containerize it, and you can run that application in Azure App Service as well. And so if you don't need full-blown orchestration, you could actually run your container on app service. Container instances. If you need to run like one single container or maybe a couple of containers, and you don't want to manage servers or have a full-blown orchestration system like AKS, container instances is a good option. And container instances is not really meant for running web applications. You can use it for that, but it's usually used for running other types of applications that need to run as containers that aren't web-based. And then we have batch, Azure batch. So if you have a workload that just needs to run a batch process, a good example is like, I have this file format and I need to have some sort of process that changes my file format into a different file format and moves the files over to some other location, right? You can actually containerize workloads and run them in Azure batch. Azure functions. So if you have event-based or event-driven workloads where you just need a piece of code to run for a short amount of time, and maybe you have a bunch of Azure functions kind of strung together, you can actually run containers on Azure functions as well. And then Service Fabric, if you need to run Windows containers, this is a good option. You can run Linux containers on here as well. And this is basically another full-blown orchestration system. Now, this was built by Microsoft, where AKS, or rather Kubernetes, was developed by Google, and Kubernetes is open source. Service Fabric is open source as well, but Kubernetes is basically everywhere. Now, a lot of the technologies that you'll see in Microsoft Cloud are actually powered by Service Fabric. So if you're familiar with Office 365 or Windows Intune, or even a lot of Azure components, on the back end, they're actually powered by Service Fabric. So when a lot of users are using a service in Microsoft's cloud and it needs to scale, Service Fabric will automatically do that scaling for you. And then we have something called Container Registry. This is just a place to store your container images. And then you have OpenShift, developed by Red Hat. So this is actually running Kubernetes under the hood, and it gives you a full-blown orchestration system for containers. Now, there are certain scenarios of where you would want to run containers and what service you would want to run them on, and that's basically what this list is. I did go through a number of these things on the previous slide, so I'm not going to go through all of these. But again, the Container Registry is a great place to store your container images, as well as Helm charts if you have those Helm charts, right? So there are a number of supporting services for containers as well, where you don't necessarily run containers on them, but they help you manage your container workloads on Azure. So Azure Container Registry, so the acronym for that is ACR. There's something in there called tasks, and with tasks, you can do a number of different things. Now, if you think back to the previous slide where I broke down the way that containers are compared to virtual machines, containers still have an operating system. They still have an application framework, and they still have dependencies, right? So you, as a system administrator, still need to patch and update those layers of the container images, right? And that can be a pain, right, to keep those updated. So you can actually use ACR and automate the patching of that those different layers, right, to make sure that you're staying secure. And then there's something called Azure Defender. This is a security tool, a security service that runs in Azure, and this can scan your images that live in your registry so that you can make sure they're secure at all times. And this will tell you if there are issues in your and/or security holes in your container images, and it'll give you a list on a nice dashboard so that you can actually go and fix those. And then Azure Defender also works against Kubernetes. And so if you're running AKS clusters, you can use Azure Defender to show you security holes and security flaws in your Kubernetes clusters. That way you can patch those and make sure they're secure as well. As you're running workloads for companies, they don't want to get hacked and they don't want to end up in the news, right? For a company that's been hacked by, hackers from wherever. So the security is extremely important, as well as patching your containers is important as well, because that's a part of your security posture. And so even though we're running containers, we still need to make sure that security is front and center and always top of mind. Now, you need to monitor your containers as well, and we have a service in Azure called Azure Monitor. You can use this to monitor servers and PaaS services as well. But you can also use this to monitor your container workloads, right? So you can monitor your Kubernetes components. It supports, Kubernetes cluster. You can also use it to monitor things like Azure Container Instances, OpenShift, or even Azure Arc. And we did talk about Azure Arc, but that lets you manage Kubernetes environments across multi-clouds. Azure Monitor for Containers also lets you monitor Docker images and other container images. So it's a great solution, right? And then you have Azure Policy. Now, what is policy? So going back to, Defender for Kubernetes, for example, if you have security issues, or you need to make sure something's patched, or you need to make sure that let's say you have a firewall in front of your Kubernetes environment and in front of your pods, you can use Azure Policy to monitor to see if you have a firewall or don't have a firewall. And if you don't have one, Azure Policy can actually enable that and turn it on. Or you can have it alert you so you can go fix that issue, right? All right. So now we're going to go through some use cases of containers, and just to give you an idea of how these work, and we'll go through some of the architecture, right, of the containers. So I keep talking about, when you get into the business world, and you go work for companies, or maybe you start your own company, you'll have applications, or those businesses will have applications, and they'll want to move those applications to the cloud, right? And they may want to containerize those applications as that move to the cloud. And there's different approaches that you can take to containerizing those applications, right? And this is a very simplified, basic process and architecture for containerizing an application and moving it to the cloud. And one of the things is, that business may not want to rewrite the code for that application. They may want to containerize it and move it to the cloud instead of rewriting the code for, running on basically like a PaaS service, platform as a service, right? Or rewriting that code to run as a microservice. And we'll talk about what microservices are in a couple of minutes here. So you could take a process like this, and you could containerize your existing application, right? And then you push that application up to Azure Container Registry, and then through an Azure DevOps CI/CD pipeline, right? You push that container to, AKS running on Azure, or this could be ACI, or it even could be Azure App Service. And then on the back end, you would have a database, maybe MySQL or even Microsoft SQL database, where your data is being stored, and your container or containers are able to communicate with that database. All right, so this is a very basic architecture for running a container on Azure, and a use case for containerizing your application. Another use case, and this one's way more complicated, right? As you can see from the diagram, you may go work for an organization, or you may, launch a startup or your own business, and you may want to run your applications as microservices, right? If you're familiar with a service like Netflix or even Amazon, right? They're running that service, right? Netflix's streaming service is running as microservices. So all of the things you see when you log into the Netflix streaming service are running, like the different parts of the Netflix service are running as microservices. So if a part of the service breaks, like let's say the rating system, how you can rate movies or you can rate shows, if that breaks, that one microservice is down, but the rest of the application still runs, right? Same thing with a mobile app. Maybe a part of the mobile app is not working, but the entire mobile app as as a whole is still running, so you can still use other parts of that mobile app. That's what a microservice is, right? So you take the different components of the application and you develop those and you couple them together, but they're loosely coupled, right? And then they run as one unit of code, right? So one application, but they communicate with each other to power that application. Well, you can run microservices in Kubernetes, and actually Kubernetes was developed with microservices in mind. And so you can run pods, and that's what these are. And I'll get into the architecture as microservices. These can each be a different component of the application that you're running. And there's like different objects and services that also run in Kubernetes that can make up an application. Now let's just talk through the diagram briefly. So here would be like a client application, or this could even be, this could be an on-premises full thick client, or this could be a mobile app that you're accessing from a mobile device, or even a web-based app that you're accessing through a web browser, right? So your end user is going to access your application here. And then when they access the application, traffic is being routed through networking technologies. So we have an Azure load balancer to the components of your application back here that are running on your Kubernetes cluster. And so that traffic has to route through this path, and it gets to the different components that make up your actual application. And those are the microservices. So each one of these would be a pod, right? And these pods are running a container or multiple containers. And again, this could be Docker, this could be containerd containers. It could be a number of different, runtimes, whatever you decided to leverage. And so, your different microservices are running here as pods, and then these services can talk to, or these pods, aka containers, can talk to other services on the back end. So like SQL Server, you might be retrieving data from here to return it back to the end user. And here's a Cosmos DB service. So you might be retrieving other types of data from this that's leveraged in your application. So this piece is the core of the application. And then down here, you have a number of supporting services, right? That's why this is labeled as utility services. And so you might have Elasticsearch to power search in your application. And you might have Prometheus to help with monitoring of your application. So here you have your front end, you have your back end services, and the databases count as the back end as well. And then you have utility services that help power and manage your application running on Azure and running in Kubernetes. And then down here, you also have additional utility services. So Active Directory, and I think you had a session today that talked about Active Directory. You'll have monitoring here that integrates with Prometheus, so you can see what's going on in your environment and with your application, let's say if it breaks. And then you also have Key Vault, so you can store secrets and make sure your application and your secrets are secure away from hackers, right? And then over here, you have your CI/CD process, right, with Azure DevOps. And this is how you actually you develop the code and you push it up into Azure DevOps, and you have a process to push that code into container registry and basically deploy that into your Kubernetes cluster, right? So that actually brings me to the end of the session. That was a lot of, actually sorry, I'm ahead of myself. I have two more use cases. So here's an Azure batch example of that. So remember I talked about being able to run containers on batch service. So if you need to just run, different batches to process things, right? So an example here is generating reports, resizing images, and converting those from one file type to another. All right, so you would import the files here, and then there would be a job that runs, right? A containerized task. And you would have another job that runs here, containerized task, using the batch processing engine. And maybe that's moving it over to a virtual machine here, right? And maybe it's moving some other images through a containerized task to another virtual machine, where then some other process is going to work with those files, or maybe it just stores those files there, right? So this is just an example of using Azure Batch with containers. And then you probably heard a lot about machine learning, right? AI, data science. Well, we can actually run machine learning. We can use containers with machine learning. In fact, this is very, very common. I've worked with data scientists where they're building out their models, and their models run in containers. And those models are actually running on Kubernetes clusters, or maybe they're running their models in Azure Container Instance. So it's a very easy and very quick way, and a very easy and straightforward way to run your machine learning models. You can run them in a container, and then you can also take those. You can build your models maybe on your machine, push them up to or containerize them, push them up to a cloud service like Azure, and go ahead and have them run there. And maybe you need to expand those models, right, like we're showing here. So duplicate them and scale them out if you need many of them, right? And so you can actually do that with containers as well. And so if you go down the data science path and maybe you become a data scientist, you will probably end up working with containers. So it's important to at least understand containers, how they work, and how you can use them. So that brings us to the end of my session. There's a lot of information there. So I think this is being recorded, so you can go back and watch it. I will also make this slide presentation available to Kazim, so he can share it with you all if you're interested. And Kazim, I don't know, do we want to open it up for a few minutes for questions?
Yes, Steve. Thank you very much, Steve, for the session.
Yeah. No,
are you able to hear me, Steve?
Yes, I can.
Okay, so I don't know. So if you can stay on for about 5 minutes to see if there are questions to respond to before the next speaker comes online.
Yeah, I can.
Okay. So just one moment. Let me see if there are questions from the participants.
Yes, we have a question. So someone has a question. Okay, my question is that containerizing, is it like a field on its own where all you can just do is maybe getting or existing apps and just containerizing them? That's my question. Like, is it a field on its own?
Yeah, it was hard to hear that question. Can someone, Kazim, can you repeat that?
Okay.
Or summarize the question.
Okay. Can you come again? Yes, with the questions. I can hear what you're saying.
Okay, it's actually a question that containerizing applications, like if you build an application, then containerize it, is it a career path on its own, or it has to do with other fields too?
Okay, you're saying if containerized application is a career path on its own, is that it?
Yes, that's the question.
Oh, okay. Yeah. Yeah, it actually is. Yes. If you want to have a career in containers, you can. Right? So there are a lot of complexities that come with containers, and so many businesses need talent that know how to work with containers and know how to work with the technologies. So yeah, exactly. So let's say, for example, if you wanted to work for Microsoft, right, just as an example, they need people that know container technologies. So you could go down a career path focused on containers. In fact, my career right now is centered around Azure, so cloud, DevOps, and containers. So great question.
Okay. So I have a question about Docker containers. So is are Docker containers stateless?
Yeah, Kazim, it's hard to hear.
Oh, okay.
If you could repeat what the question was.
Okay. Sean, are you able to help me repeat, please? I'm also finding it difficult.
Okay. My question: are Docker containers stateful or stateless?
Is it what or what? Is Azure container what?
Docker, we talked about right? Like Docker is one of the container subjects. So my question is: are Docker containers stateful or stateless?
Okay, Azure container stateless.
Or stateful, yeah.
Okay, Steve is asking if Azure containers are stateful or stateless.
Oh, so they're typically stateless. You can run containers, you can run stateful containers. I would recommend that you don't do that. But if there's a compelling reason to do that and you need to, you can run them as stateful. But the recommendation and the best practice is to run stateless containers.
Okay.
Yep, good question.
Oh, okay. Here's what we should do, Steve. I think if you can, I believe you've shared your social media handles. So if there are questions, or those that might like to just reach you themselves, or if they send it to me, then I can get them across to you.
Yeah, sounds good. Sounds good.
Oh, okay. So do you mind quickly help us do that again? You know, your social media handles now for people that like to follow you.
Yeah, let me do this. I'm gonna share my screen. Hold on. And we're gonna use OneNote. I mean, we're gonna use Notepad. All right. So
Yes.
okay, perfect. Yeah. So there's my Twitter. Right. So yeah, follow me there.
Okay.
If you have any questions, go ahead and tweet me or send me a DM. And there is my blog as well.
Okay. So thank you so much, Steve. Thank you very much again for your time and sharing your knowledge with us.
Thank you, everyone. And yeah, I hope to present again. Thanks, Kazim.
Okay. Thank you very much, Steve. Thank you.